Hi, and welcome to my new topic on constant multiple rule. And video 1 is on the proof of that rule. The constant multiple rule is if you C is a constant times some function f of f. So the derivative of a constant times a function is equal to the constant times the derivative of the function. So again, the derivative of a constant times the function is equal to the constant times the derivative of the function. So let's do proof for that. I'm going to do proof by the definition of a derivative. I'm also going to do the proof by the product rule. So the definition is f prime x is equal to the limit as h approaches 0 of the f of x plus h minus the f of x all over h. So if we do c f of x, if we do the derivative of that, we have the limit as x approaches 0 of the c of the f of x plus h minus the f of x all over h, and that's the limit as h approaches 0. Make that a limit. We have, notice we have the c as a common factor, so we take the c out. We get the c outside of f of x plus h minus, oh, this, I forgot to put a c in here. This is the function f of x is this function c of f of x. So f of x plus h goes here, and c of f of x goes here. So we take the c out. So we get f of x as a common factor over h. And so that's the limit as h approaches 0. And that's c times the f of x plus h minus the f of x over h. And so that's the limit as h approaches 0. And that's c, oh, let's go with a c in front here now. C times this limit of the f of x plus h minus the f of x over h. So this is definition of a limit rules that any number of times the limit, you can do the limit of the product. So that's c, the limit of x approaches 0 of the f of x plus h is right here. So that's f prime x. So that's a c there, because again, f of x is c, f of x, that's right here. And we take the c out, and the limit product c times the limit is the same as the limit of c times this constant times this expression. So that's one proof, one way to prove it. We can prove it by also prove it by the product rule. So we have c f of x, the derivative, is equal to c f derivative of x. So if we take, and I'm going to use an f and a c because I'm used to, even though this f of x is here, I'm going to say this is the f and this is the g. So f times g, if you take the derivative of that, that's the same as f prime times g, add on f times g prime. So the derivative is, if you take it right here, I'm taking it from right here, the derivative, okay, there it is. So f is c, so c derivative times g, which is the f of x, plus f, which is c times f of x derivative. So f is c, g is f of x, so I did the derivative of c and the derivative of g, so that the derivative of c is a constant, so that's 0 times the f of x, and the derivative of f of x is f prime x, and that's 0 plus c f prime x, and that gives us c f prime x. So that's using the product rule, we have the derivative. So I did the derivative by the definition, I did the derivative by the product rule. So what it means is that any constant, when you have a constant times some function, then you don't have to worry about this constant, just write the constant outside and do the derivative of this function. So that's the proof part. And if you like my video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.